Avon Resources Limited is a gold exploration company with significant projects in British Columbia, Saskatchewan, and the Yukon. Trading on the TSX Venture Exchange, symbol ABN, and the pink symbol ABN-AF. Surrounded by world-class gold deposits and mines, Avon's 23,000 hectares Forest Kerr Gold Project is located in the heart of the Golden Triangle in northwestern BC. For more information, visit us at avonresources.com.
Welcome to the Goddard Report. Comments made on the Goddard Report and TalkDigitalNetwork.com are an expression of opinion only. Here is Jim Goddard.
My guest is Tom Raycove. He's the CEO and founder of Disruptive Logic. His website, disruptedlogic.com. Welcome back to the show, Tom.
Hi, Jim. Thank you very much for having me.
Artificial intelligence. How deep is it? Is it just another layer of software? And how in depth can we get with AI, and how does it work?
Well, you know, Jim, over the past few years, artificial intelligence, or AI, has really become a much bigger part of our lives. And we're seeing it, infiltrate more and more into our day-to-day activities. I guess from a technical or even a simple explanation of what AI is, basically it's where we're using machines to help us make decisions, and we're trying to make those machines smarter and more capable of dealing with common everyday problems in the same way that you and I would, essentially emulating human thought and our behavioral processes.
Well, once we program all that stuff in, how do we know it's going to be doing exactly what we want and not doing what it wants?
Well, I guess a good way of looking at it is that you and I make a number of repetitive decisions every day, including things like what radio stations do we want to listen to in the morning. And with our AI or smart machines, we're designing these to make these decisions for us by allowing the AI to enter our lives and develop a greater understanding of what you and I are all about and what we like. And we're doing that, Jim, with a certain degree of trust that the AI is actually working in our favor.
We've heard a lot about self-driving cars. But what's the difference between a self-driving car and a driverless car?
Yeah, and that's a really good question. So let's make a distinction here about what those differences are. So a self-driving car essentially aids a human driver by taking care of all of, or the majority of the tasks that are related to driving, such as, guiding you or taking you to a destination that you've programmed into the car. Or helping to do lane changes, or a really good example of near self-driving technology that I saw the other day. I saw a commercial. I'm not sure what the car was for, or what the commercial was for the car. I think it was Lincoln or something. But they were boasting about how the car had, rear impact detection, front impact detection, blindside driver detection, and would auto-correct for you as you're driving if you allowed it to. So those are good examples of what self-driving cars would be doing for you. They help with the decision of driving, making decisions, but allowing the human to be able to take over control if desired or necessary. Whereas a driverless car is actually an autonomous car. It doesn't actually have a human in it. These cars are completely driving themselves without any input at all from a human. And I think a really good analogy for that, Jim, would be that of a modern-day passenger aircraft, like the Airbus. It has the ability to self-fly, and for the most part, the pilot is just there to make sure that nothing goes wrong, or to take over if something does go wrong. That would be a good example of a self-driving car. Whereas an autonomous example or analogy with the aircraft would be more like the military drones that are programmed to fly to a very specific destination and then fly back, and perhaps even do something when they get to that destination. But the drone is in control of making its own decisions, such as responding to situations like a missile attack or some other situation like flying around a building. And it takes actions where it needs to, all without the necessity of human control.
Now, self-driving cars use a number of systems to make them work. Lasers, microwave, radar. In fact, one of the concerns I have about either assisted driving with a robot or the robot doing the driving is these things are basically coming a microwave oven with a door open. You know, they're broadcasting all these radio frequencies.
Yeah, and that's an interesting problem as well. We've heard a lot about how electromagnetic energy affects us as humans. We've heard a lot about people that live underneath power lines. I know that today, Jim, where I'm at, it's raining, and it's raining really hard. When I take the dog for a walk and we walk under the power lines, I can actually hear the rain sizzle and crackle on the power lines. That's how hot those lines are. It makes you wonder about what kind of impact this would have on us, have on our brains, have on our physiology, have on our mental state, and so on.
Well, I know there were places in downtown Vancouver where some of the underground power lines weren't properly insulated, and dogs were getting zapped when you took them for a walk, and they lifted their leg.
I've heard about people also getting zapped when they've stood on metal plates that are covering those power supplies.
Exactly. We'll have more with Tom Raycove right after the break.
I'm Larry Ray, President and CEO of American Manganese, Inc., listed on the TSX Venture, ticker symbol AMY, A-M-Y, with proprietary patents in the U.S., China, and South Africa. Our focus is on recycling lithium-ion batteries for electric vehicles. China recently legislated the responsibility for recycling onto their electric vehicle manufacturers and importers. For more information, please visit AmericanManganeseInc.com or phone me, Larry Ray, at 778-574-4444.
Arctic Star Exploration, operated by a team of proven mine finders, is focused on diamonds in Finland and the Northwest Territories of Canada. A work program is planned for our Finland property that contains diamond-bearing kimberlite. Arctic Star trades on the TSX Venture Exchange, symbol ADD, and the Frankfurt Exchange, symbol 82A1. Please visit our website at arcticstar.ca or call us at 604-689-1799.
Welcome back. We're speaking with Tom Raycove. Tom, what's another description or an interesting application of AI in real life today, right now?
Well, I think a really good example that we can all relate to almost immediately would be voice recognition or speech recognition on our cell phones. And, this is actually a lot more complicated than you would think initially. Yet it's a transaction that happens just so incredibly fast. And by now, I'm going to assume that by now most of us have spoken out a message into our cell phone so that we can text it to a friend. And Jim, I'm willing to bet that we could do an entire show just on how this technology works. But the basics are that when you and I engage in a conversation, when we speak with one another, we're exchanging tiny blocks of sound that are assembled by our brains very quickly and processed into sentences that have meaning to us. And the conversation that we're having right now, for example, is a series of these small blocks of sound which are made from a combination of letters, individual letters, and we combine them in certain ways to create certain types of sounds. But you and I don't always say the same things the same way. You might draw out a word for an effect, whereas somebody else might say the word very quickly and with an accent. Our human brains are able to process this information extremely quickly through a combination of our experiences and through comparisons. AI itself works in kind of a similar manner. It's analyzing these blocks of sound and then comparing them to a database of similar blocks of sounds, comparing the context, and trying its best to make a match or a decision, and then displaying on the display of your phone what it thinks you've just said. And as the AI gets a little bit smarter, it becomes more and more familiar with the nuances of your voice and therefore becomes a little bit more accurate. But it's actually really quite funny what the AI can get wrong.
Well, what's an example of that?
Well, I had a text message that I was going to send out to a buddy saying something along the line of, I will text you a little bit later this evening. And it actually came out through the AI as, I will sex you a little bit later this evening. And thank goodness I caught that, because it would have definitely had a little bit different meaning than I had intended.
Also, what happens if you have a sore throat and your voice sounds different?
Yeah, that's a really good question. I really don't know what would happen in that situation, but I mean, there's a number of websites that we can go to where you can see text messaging fails, and yeah. Or what happens when you've got somebody who's not a native speaker of the language that you happen to be speaking in, trying to communicate information to you. And there's yet another good application of where AI can come in really handy, and that's translating on the fly. Maybe somebody in France wants to send me a message, but they don't speak English, and they could use their AI to convert their dialogue into English text for me on the fly.
Tom, do you have any interesting examples of where AI kind of got the wrong message or mixed it up?
Yeah, definitely. We all hate ads, but more accurately, we hate ads that aren't really relevant to us or don't really have any importance to our day-to-day lives. And digital advertising is a great example of where some of this AI can really mess up the message. I've got a great example for you. Do you remember the Costa Concordia that sank off the coast of Italy?
Yes, the captain showing off to his girlfriend, bragging about how close he could take his cruise ship to the shoreline. Oops.
Yeah, and apparently not that close. I remember watching a lot of news stories online for that, and what was absolutely fascinating is that the keyword matching systems that were being used at the time, the ads that they were displaying were analyzing cruise ship and therefore display ads related to cruise ships. And while you have the ship that's sinking, it's an environmental disaster. It's a financial disaster for the company. The captain made a huge, mistake in his decision-making process. People lost their lives. The ads that were displaying were things like 75% discount on your next cruise ship vacation. Now, in hindsight, we can kind of laugh at that a little bit, but wow, talking about insensitive and highly inappropriate. And that's a really good example of where AI can fail when it comes to, trying to interpret what a situation is and how to best respond to it.
What about other practical applications? Say, your car, it's making a weird noise. Could AI diagnose it so you don't spend a fortune having the mechanic go through it?
Yeah, so that falls into something that we call case-based reasoning. And in this approach, in case-based reasoning approach, what we're doing is we're comparing information from the past to something that we know right now. And we're trying to come to a conclusion based on that past experience. So with the engine knock in your car, let's say the result is because of low oil. We know this because the last time your engine made a knocking noise, it was because there was low oil levels. Plus, when we compare that to other sets of historical data that we have, such as the last time you put oil in your car, let's say it's been quite some time ago, more than enough time for your engine to have consumed the oil that you put in, plus compare that to other service records, and knowing that everything else in the engine is just fine, it's easy through case-based reasoning to conclude that the reason why your engine is knocking is because the engine levels or the oil levels in your engine are really low.
Can AI also be used to predict events, say who's going to win the Oscars?
I'm really glad that you asked that question, because one of the things that we've been doing at Disrupted Logic for the last couple of years is predicting the Oscar Best Picture. And we've actually been quite successful in doing this. We won't talk about what happened last year. That was a little bit of a surprise. But we've been very successful in doing it. And the way that we've done it is through case-based reasoning, where we use massive volumes of historical data, thousands and thousands of data points. We make a prediction, and then we compare that to a result that we actually know. So to give you an example of that, to predict the 2000 Oscar Best Picture, we already know who won that Best Picture. So we set our AI upon the historical data that we have. We have it make a prediction, and then we test that prediction against the result that we actually know. If the AI gets it right, we move on to 2001. However, if it gets it wrong, we run the prediction again and again and again until we get a successful match. And after going through tens of thousands of these types of learning cycles, we eventually tune the AI and the machine learning algorithms to be able to successfully predict a future event that hasn't happened yet. With our example of the Oscar predictions, based on the historical data, which was based on finite data sets, we were actually able to hit an accuracy ratio or rate of 100% to the 17th power. However, when we applied to a future upcoming event where we have infinite variables, the AI isn't quite at that 100% mark. We hit 100% for 3 years in a row, but last year we guessed wrong, or predicted wrong.
Well, you had it programmed to think like a 65-year-old Jewish white male, because that's who makes up the majority of the Academy panel. However, I think they felt a little guilty about the Oscars being called the White Acting Awards.
Well, and fair enough. And one of the things that we did not take into consideration, I mean, the team as living, breathing human beings, we knew that there was a cultural event that was happening simultaneously. But we didn't have time to program our AI to take that into consideration. And we knew that that was a risk for last year's prediction. And of course, the cultural event that did take place was a very defining, determinant in who was going to win. But again, we can look at that as a good example of how when you've got enough data, had we had that data in place, there's no reason why our AI could not have predicted the result of that future event.
We'll have more with Tom Raycove right after this.
I'm Brian Fowler, president of Blind Creek Resources Limited, listed on the TSX Venture Exchange, ticker symbol BCK. Blind Creek is focused in the Yukon, Northwest Territories, and British Columbia. The company's key property is the Blend Project, one of the largest undeveloped lead zinc silver deposits in Western Canada, plus plans to advance the recently acquired, fully permitted historic engineer gold mine in the Atlan District of Northwestern BC. Check us out at blindcreekresources.com.
In Goddard we trust.
Welcome back. We're chatting with Tom Raycove. Tom, is AI just the next level of software?
Well, I'm going to answer both yes and no to that one. AI is
you're now well qualified to be a politician.
Well, maybe there's a career path if AI doesn't work out for me. AI is constantly changing and improving. And as it does so, we're learning and finding new applications for it. I remember as a kid, way back in the late 70s, not that I want to date myself, I used to experiment a little bit with AI, and back then, it was written in BASIC. There was a program that I was using, I think it came out of the labs at MIT, and it was called ELIZA. And essentially what it was a 20 questions type of program. You remember that game, 20 questions? I'm thinking of something, and then somebody asks you a question. You get 20 questions to figure out what you're thinking of. And it basically interacted with you on that same kind of level, and it would ask you, what are you thinking of? And you would type into the computer, dog. And then it would ask you, what's unique about a dog? And you'd type, well, a dog has fur. And then the next round of gameplay, Eliza would ask you, what are you thinking of? And you would say, well, I'm thinking of something that has fur. And it would ask, well, is it a dog? And you would say, no, it's not a dog. I was actually thinking of a cat. And Eliza would say, well, what's the difference between a dog and a cat? And you would type in, a cat meows. And you get the idea. And it would keep going through different sets of reasoning based on the logic that you were essentially typing in. Well, it's a very primitive form of AI, and AI has come an awful long way since then. To suggest that it's the next level of software, yes, you can definitely say yes to that, but it's much, much more than that. It's actually an enhancement to a lot of the software that we're already using. And Jim, I know that you use an audio editing program, and I'm absolutely positive that there's a form of an AI component that allows for intelligent automation with that editing program.
Yeah, I mean, for example, I've got heavy rain falling outside my window right now. I don't want the sound of rain in my broadcast, so I go and take a sound sample between the times we're talking where there's just the sound of the rain, and I can highlight it, then put it across the entire audio track, and it'll take out the sound of all the rain.
And in the old days, that kind of filtering would have been an awful lot of work and probably would have driven you a little bit crazy. And you'd be wishing you hadn't recorded audio on a rainy day. Even to that context, if the coffee cup that's sitting on your table fell to the floor and made a loud crash, isolating that in the old days would have been an awful lot of work, and you would have had to go back and cover it up with ambient sound and so on. Well, the AI component of your software does this automatically for you, and it does it much faster and far more accurately. So is AI a next level of software? Absolutely yes, but it's so much more than that.
Well, what's the difference between the software we have on our computers right now and AI?
Well, I guess, Jim, from a technical perspective, the big difference would be that the software that we use day to day is more of a procedural-based approach to solving problems, and it's frankly just not that intelligent. And what I mean by that is that the code has been very specifically written to take very specific actions and to react to events based on those specific actions. So, I'll give you an example. Microsoft Word. It allows me to type. It's a word processor. And I can spell check, but the spell check isn't really AI. It's more of a procedural process of comparing the words that I've just typed to a dictionary that it has in its database. If the word that I typed is not in the database, the word becomes highlighted as a possible error. And I can click on that word, and I'm given a menu of words that closely matched what I've typed, and I can pick from that one, or I can pick from that list the one that I think is correct. Whereas in an AI-driven program, it would be more algorithmically driven and learning-based. It wouldn't be limited to just a small set of specific actions or events, but instead it would be learning from what I'm doing and trying to do, and it would react accordingly. So using that Microsoft Word example, perhaps it would allow me to dictate into the software, and the software would voice recognize what I'm saying and transcribe my words onto the page and correct them as I go along. But, and I'm just inventing a scenario here, but let's say perhaps the word processing software also knew that I was attempting to write an academic document for a book report that I was doing for school. And it would take my spoken words, reformat, and restructure them according to the rules of grammar and properly format my document for the paper that I'm about to turn in. And it would do this for me intelligently and automatically versus me having access to those individual components but having to drive all that myself.
What about action on the stock market? Right now, we say the robots are doing the trading. The humans are kind of passengers. When they see a trend, they absolutely react instantly, sometimes perhaps a little too fast.
Yeah, for sure. And with the stock market, as you've just indicated, there is a certain degree of automation that happens, but they're still using conventional analysis programs, which at the end of the day, Jim, they still require a great deal of human supervision because it is your money that's at stake after all. But as the AI starts to become more of a driving force, these AI-driven programs are going to be more capable and able to learn from the decisions that a human makes and would then be able to drive the predictions on their own. But imagine applying our Oscar prediction algorithm to the stock market, and imagine being able to do so without having a panic attack because the software is always 95% correct. Now here's the panic part. Remember, it's also 5% wrong.
Will AI be a big boon for the surveillance industry and the surveillance state?
Oh, absolutely, Jim. Absolutely. I have a friend who's a bit of an armchair conspiracy buff. And for the longest time, he's believed that the government would soon be forcing all of us to embed RFID chips under our skin so that they can track us. But you know just as well as I do, the logic just doesn't stand up when you really think about it because RFID chips are really expensive. Medical procedures are time-consuming and expensive, and people in general just don't like being forced to embed things into their bodies and most likely would resist in some rather unpleasant ways. But what do you have in your pocket right now, Jim?
Well, what if I said I didn't have any pockets in what I'm wearing right now?
I would say the rating of the show just changed. I'm referring to the phone that most of us have in our pocket. You happily bought that phone. You carry it everywhere you go. In fact, you're more likely to forget your wallet at home than you are to forget your phone. And we have to keep in mind that that phone that you have on you right now is silently tracking absolutely everything that you do. Now, think of everything you do as data. You walk to the Safeway at the corner of your street at 5 p.m. on Wednesday. You're in there for 15 minutes, and then you walk back to your home. That's data. This data, it gets collected and stored, and it's collected 24/7, 365, and it's collected from everywhere, from everyone. When you interact with Facebook and other social networks, that's more data that's being collected. The things that you say and do online, more data. Our interview, data. These big sets of data can be analyzed to make predictions. At Disrupted Logic, we use big data sets like this. And just to be clear, we're not tracking everything that you do Big Brother style. We like to brag that we're the good guys. But we use this type of data to make predictions about the products and services that you would like, and that would be of interest and benefit to you. But what happens if you have the bad guys who are also looking at the same data? They can also use these big sets of data to make predictions about you. You saw the movie Minority Report?
Tom Cruise.
Exactly. Forensic scientists, in the movie Minority Report, they're using the predictors, the twins that can predict who's going to create a crime, right? And they arrest you before you commit the crime. Well, forensic scientists today use similar predictive data sets to, well, not similar to, thinking about it, but they use data sets to predict and profile criminals to help us determine who a killer is or what a killer's pattern is going to be, or to define attributes and habits of a killer's behavior. With AI and vast amounts of data that can be drilled through, you can not only create profiles of potential criminals, but you could also use this data to predict who the creator actually is. And we can argue that that's a benefit to society, but when it gets used in bad ways, such as from a surveillance perspective, well, gee, just imagine some of the type of profiling that you could use to spy on nations.
Well, what kind of an application, or how could you spy on a nation just with cell phones?
Jim, I was in Seattle a couple of weeks ago, and one of the military ships had docked, and the sailors were walking around having a really fun time and doing whatever sailors do in Seattle. I noticed, though, that almost every single one of them had a cell phone, and they were all busy with it. They were all texting or doing something. Now, remember, that very specific cell phone is tied and connected to a very specific person, and that person does very specific things, including hanging out with other specific people who also have cell phones and who just happen to be sailing around the world on a military ship. It's not a far reach to be able to use AI to make surveillance predictions about that ship. So think about this. You could easily determine what ship it is, who most of the sailors are who are on that ship, where the ship just came from, and where it's about to go to next. Ships have a nasty habit of traveling in straight lines. And even what the mission is that ship is about to serve based on what people are communicating with each other. I'll use this as an example. I saw a news story about the U.S. government and their cruise missiles. I believe they're called Tomahawk. Is that correct?
Yep.
The story was filmed in a top secret location where these missiles were being stored, and the reporters were interviewing a real live person who was, like an executive manager of this facility, but that live person had a name, and they happened to have a Facebook and a LinkedIn profile. And it didn't take very long for people to figure out what city these missiles were being stored in by looking at the person that managed the facility. Now, imagine applying surveillance AI to that very same scenario. It wouldn't take long to figure out exactly what building in the city the missiles are being stored in. And then add to that the sailor data that we just spoke about a few seconds ago, and it becomes a very frightening situation where AI can be used to predict some very, very sensitive information.
Sure. Could it predict individual behavior? Say, every Saturday afternoon at 4, you go for an ice cream?
Yeah, absolutely. I mean, Jim, you do things, I do things, our friends do things. Those are all data points. And at a certain point, there's not going to be any more secrets left. Someone or something somewhere is going to know what we do, when we do it, what and when we're going to do some other thing next. And to me, it isn't a matter of if, but it's more of a matter of when and who.
Will people program AI, or will AI program people?
You're familiar with Ray Kurzweil?
Probably not.
He's a data scientist. He's been around for a long time. I believe he invented the Kurzweil organs, also digital cameras. And he talks a lot about the concept of the singularity and transcendence. And the singularity is that point when our computers and the intelligence of our computers has outgrown our capacity to be able to understand and comprehend what the computers are doing. And people like Ray Kurzweil and Elon Musk believe that that moment isn't very far away, and that we're quite literally just talking a few years from now. And right now, people are programming AI, but pretty soon AI will be programming AI, which we refer to as machine learning. And a very short time after that, we as people will no longer have the capacity or the ability to understand what the AI was doing. Now, Jim, I want to refer to an experiment that was done a couple years ago, and I apologize, I can't remember the name of the project, and I will look it up when I've got some time, and hopefully you can post it up later. But the basic essence of what these scientists were doing was a stereo audio processing project. And again, like I said, I can't remember the exact details, but their goal was to use a matrix of CPUs to analyze and process the audio, but at the same time to reduce the actual number of CPUs that were needed to process that audio to the lowest possible number of CPUs possible. When they set AI upon the task, the result was that the AI needed even fewer CPUs than the scientists had needed and even believed was even possible. In fact, so much so that the scientists were unable to not only explain the results and how it was possible, but even to replicate those results on their own without the assistance of the AI. And to this very day, they still don't know how this happens.
Well, do you have any examples of where you might have something that's really smart and controlling things and something that thinks it's smart but maybe isn't?
How about, let's imagine an ant. What's the ant's perspective of a human? Does it understand who we are, what we're all about? My money is a solid no on that. To an ant, if it were capable of thinking this way, we as humans to an ant would be like gods. However, the reverse of that is that we as humans, we know quite a lot about ants. We also know that there is no possible way on earth to be able to teach an ant about us. The relationship that ants have with us and we have with ants is what the relationship is. And the only way that we can find a middle ground would be for humans to either devolve or ants to evolve.
So is there going to be the same kind of issue when it comes to AI?
Absolutely, and this is where scientists and futurists like Kurzweil and Elon Musk are seeing similar types of issues. At the Singularity, our technology or our AI will almost become like gods to us as mere mortals. Their feeling is that once we've hit that singularity, humanity is going to need to transcend and evolve if we're to keep up and hope to remain in control. That we're going to need to adapt and adopt the technology into our actual physical biology so that we can keep up and understand where our technology is going and what it's doing. And it's at that point that this question becomes a very interesting one. Will we be programming the AI, or will the AI be programming us? And to that I say, stay tuned, and we'll find out in the next few decades.
Well, we have to program an AI like Isaac Asimov did with his laws of robotics. It can't harm you. It can't, through its inaction, allow you to be harmed. And then self-preservation.
Well, and I remember there was a Star Trek episode where they confused the AI, and the AI self-destructed when it was presented with a paradox. I guess the big question that I would have with that, Jim, is what's the guarantee that the AI will obey the rules?
I think they made a movie about that.
iRobot.
You got it.
Yeah.
Tom, thank you so much for your help.
Jim, it's my pleasure. Thank you very much for having me on the show. I enjoy these conversations very much. Anytime you want to pick up the phone and call me, I would love to chat with you.
And my robot agrees. My guest has been Tom Raycove, CEO and founder of Disruptive Logic, their website, disruptedlogic.com. If you have any questions for the show, you can email us at info@howstreet.com. I'm Jim Goddard. Thanks for listening.
Comments made on the Goddard Report and TalkDigitalNetwork.com are an expression of opinion only. The Goddard Report is available online and mobile at TalkDigitalNetwork.com. The Goddard Report is a production of How Street Media Incorporated.